In 4.3, we may have seen something like um, we would need to factor this quadratic. And of course, now we're good now, or experienced, in looking to find two numbers that multiply to 6 and add to 5. We're trying to fill these two parentheses in with those two numbers, and we would figure 2 and 3. 2 times 3 is 6, and 2 plus 3 is 5. So, yeah, and we would be right. In this section, we will see some slightly different things. The big difference being that there's a number out in front of x squared. X squared has a coefficient other than 1. And plus 25. Okay. So the difference here is, again, we have this coefficient in front of x squared, and so it's not as easy as just throwing down our parentheses like we did before and looking at 25 and 20, looking for two numbers that multiply to make 25 and add to make 20. In fact, we won't even be able to do that. There aren't two factors of 25 that add to 20. You've got either 5 times 5 or 25 times 1, and neither one of those works. And even if we tried that, we would normally just put an x and an x, and we can see when we multiply these two parentheses out, even when we fill in these two numbers, you take these two terms times each other to get to the x squared term, and that's not going to give you 4x squared. It's going to give you just x squared. So you can see part of this is going to have to involve coefficients in front of the x. Let's make some room for those. We need to have some coefficients in front of the x's here. But now there's even more variability in this problem. Should it be a 2 and a 2 to make a 4, or a 4 and a 1? And then how is that going to work together with the factors of 25 that we're going to have to fill in? And you can see the complication that comes up. Let's try a 2 and a 2. You just have to try different stuff. And then we'll try 5 and 5. Okay, and then we'll just double check and see. We'll, say this is the solution. We got to check and see if this is the solution by multiplying everything out. So we'll take this 2x times 2x. That'll be 4x squared. And 2x times 5x, that's 10x. And then we're done distributing the 2x, and we'll move on to the 5x. And then 5 times 5 is our 25, and we combine like terms, and we get the 20x. Okay, well, we just kind of got lucky right there, because we could have just as easily tried to do something a little differently. We could have tried 4x and 1x, because that 4x times x would be 4x squared. We could try again 5 and 5, but this isn't going to work. We know it's not going to work because this did work. This is the only possible factorization. So 4x times x would be the 4x squared we needed, and of course 5 times 5 would be the 25 we needed. But when we go to do 4x times 5x, we'll get, or 4x times 5, we'll get 20x, and 5 times x will give us 5x. And so that'll give us 4x squared plus 25x plus 25. Right? And we could try all sorts of solutions, all sorts of different combinations of numbers. We could try 2x plus 25 times x plus 1. We could try, that would be 2x plus 1. 4x plus 25 times x plus 1. Let's see. I believe those would be all four of the combinations. So you can see if we hadn't guessed this one correctly right off, we could have gone through 1, 2, 3, 4 before we actually got the right answer. And the book actually prescribes a guess and check method But in the sample problems video, we will go over a more precise way of doing this. If it's factorable, what I'm going to show you is going to factor it more quickly than your guess and check, especially if there's lots of possibilities in guessing and checking. Okay, so I'll see you in that practice problems video.